Hello everyone, welcome to my presentation. I'm Lagat Hillary. So we are going to see about the computer central processing unit. This also known as the CPU. So the CPU is this also given the name processor. We have another name central processor or microprocessor. So it carries out all the important functions of a computer. So owing to these features of CPU, it is also referred to as the brain of the computer. So we have various functions of the CPU. So the first one is to coordinate all the computer operations. The second is to perform arithmetic and logical operations on data. Also, it carries out all types of calculation. We have the arithmetic and logical operations. It controls the CU, that one is the control unit. It also controls the actions of other components. It helps input and output devices to communicate with each other. And then the last function is it receives instructions from both the hardware and active software and produces output accordingly. So the next item is to see how the CPU is installed on a motherboard. So CPU is installed or inserted into a CPU socket located on the motherboard. So this socket is provided with the heat sink. So the function or the purpose of the heat sink is to absorb and dissipate heat to keep the CPU cool and function smoothly. So without this, without the heat sink, you'll find that your computer is heating a lot, so making it to function poorly or inefficiently. So what are the components of CPU? So normally we have the three main components. The first one is the ALU. That one is the arithmetic logic unit. We have the control unit. We have the memory or the storage unit. So here is a diagram of the CPU. So top there we have the central processor, we have the ALU, the arithmetic logic unit, we have the CU, that one is the control unit, and then down there we have the memory unit. So under the memory unit, it is categorized into three. The first one is the ROM, that one is the read-only memory. We have the RAM, the random access memory, then we have the cache. So as you can see on the left side we have the input, then on the right side we have the output, and then downwards we have the storage. So here we have the two illustrations of the CPU. So as you can see, the two illustrations, they have different orientation of the bins, so depending on the motherboard. And then we now see each of the types of or the categories of the CPU. So the first one is the control unit, the CU. So it is the circuitry in the control unit which makes use of the electrical signals to instruct the computer system for executing already stored instructions. It takes instructions from memory and then decodes and executes these instructions. So it controls and coordinates the functioning of all parts of the computer. That one is the main purpose of the control unit. So the control unit main task is to maintain and regulate the flow of information across the processor. It does not take part in processing or storage of data. So another type is we have the LU. So LU, another in full is the arithmetic logic unit. So this one performs the arithmetic and logical operations such as the addition, subtraction, multiplication, and division, and also comparisons. So logical functions mainly include selecting, comparing, and matching the data. So a CPU may contain more than one LU. It can have more than one LU. So furthermore, LUs can be used for maintaining timers that help run the computer. So we'll see that one in details in our next lesson. So also we have the cache and the memory. So cache, this one is the smallest, the smaller in size but faster in speed than the main memory. It can be accessed by the CPU more quickly than the primary memory. The programs and data frequently used by the CPU are held by the cache memory. So this one, they are held by the cache memory to make it faster. So if the CPU is able to find the required instructions or data in the cache, the need of accessing the primary memory wasn't arise, because the cache memory is the first one to be accessed than the main memory or the primary memory. So therefore the system performance would be boosted. So also we had the ROM and RAM. So we'll see that one also in details in our next lesson. So we have the registers as our next item. So it is also called the access memory or RAM. So it temporarily stores data, programs, and the immediate and final results of processing. So it acts as a temporary storage area that holds data temporarily. It is used to run the computer. So this one is for temporary storage. If the bar goes off, you can easily lose your contents. So this one is temporary, unlike the ROM, whereby it can store its data maybe permanently. So we have various types of CPU. So the CPU is a vital element that manages all the calculations and commands which are transferred to other components of the computer, and it's the peripherals. So the rapid speed of the CPU obeys to command of the input program. The components are dependent and powerful when linked to the CPU. So it is necessary to choose the right one and program it accordingly. The leading manufacturers of CPU are AMD and Intel. So we have the two being leading manufacturers. So in the past, the processors are employed to find the right and robust processor. The Intel 486 is rapid than 386, but after introducing the Pentium processor, all the processors are named like Duron, Celeron, Pentium, and Athlon. The various types of processor are built in different architecture, like the 64-bit and 32-bit, with maximum speed and flexible capacity. The major types of CPU are classified as you have the dual core, the single, you have the hexa-core, the octa-core, and deca-core. So we'll see the main ones. So the main ones are the single core and dual core. So single core is the oldest type of computer CPU, which was used in the 1970s. It has only one core to process different operations. It can start only one operation at a time. The CPU switches back and forth between different sets of data streams. when more than one program runs. So it is not suitable for multitasking as the performance will be reduced if more than one application runs. The performance of these CPUs is mainly dependent on the clock speed. It is still used in various devices such as the smartphones that we use at the moment. Then the next type is the 12-core CPU. So as the name suggests, the 12-core contains 2 cores in single integrated circuit IC. Although each core has its own controller and cache, they are linked together to work as a single unit and thus can perform faster than single core processor and can handle multitasking more efficiently than single core processors. So this one is the advantage of the 12 core over the single core processors. So thank you for watching. That's all about my presentation.